Hello guys, welcome to the fourth video of section 1, which is all about adopting ARIMA model for forecasting sales data. In this video, you will learn how to implement the ARIMA model in Python using a number of its packages, and this includes pandas for loading and managing data sets, as we have seen previously, matplotlib for plotting charts, and OS for setting the directory. In the course of this video recording, other packages will be introduced. Just stay tuned. In our first cell, what we are basically doing here is just to import the necessary modules as mentioned. So the next thing is to change the directory. I've closed my Jupyter notebook, so I reopen it. So there's a need for me to set the directory again. Okay, I explained the essence of that in the first video. Now let's load the data set again. Okay, let's view it by running this cell. Okay, so you can see the records being displayed on your screen. So again, we are using the Walmart sales forecast data set in its original form. That is, we are not using the modified version. Okay, so we have run the code to load the data set and we have already viewed it. So in order to use the ARIMA method of time series forecast, we only need two columns, namely the column containing the dates, values, and also sales. As far as the loaded Walmart data is concerned, this number includes dates. You can see it on your screen there and the weekly sales. Just like we did previously, we are going to filter the record. That is, restrict the data to store one and department of interest. We are doing this mainly to avoid duplicate record. I will show you what I'm talking about. Okay, so let's start by sorting the data in the data frame and let's have a look. Okay, everything has been sorted nicely. So now the data has been sorted. So we're and these are the top 5 records being displayed on your screen. You will notice in the date columns, this particular date column, that we have a couple of 5th of February 2010, 5th of February 2010 values. There's a number of them. Look at it. They are the same. So we cannot use the data like this. Hence, we need to filter the data again. The reason for these values is that they are coming from different store and also different departments. So it's something that is reasonable. It's not anomaly, but because they are coming from different stores. So this is something that is normal. So, but as I mentioned just now, we need to filter the record. We cannot use it like this. So just like we did in the previous video, we are going to select store number 1 and department number 1 records. Okay, and you will notice here that I have combined the code instead of splitting the code. I've combined them. So, and also what I'm busy doing now is just to select date and weekly sales. And you see my store here is number 1. My department here is also number 1. Let's take a look at the data. Okay, so you can see that the duplicates are no longer occurring. So we have them lining up nicely. So this is something that is consistent. So I want you to know that. So as we have seen in the data, so there, as I said, there's no trace of duplicate. So one thing you may notice in this data that is being shown is that there's a gap exists between the dates. So look at this date, is 5th of February, this is 12th. So this is something that is not normal. That means there's nothing to worry about. So because we are talking about weekly sales, not daily sales here. So weekly day, it is assumed that all these dates are weekly dates. And if you look at the difference, 5 plus 7 will give you us 12. 12 plus 7 will give 19, and so on and so forth. Okay. But nevertheless, we should be concerned if there's a gap in the date value and what was observed was something sales on a daily basis. So if you encounter this kind of problem, you may need to interpolate for the missing value. Remember, in the definition of time series data, we are talking about data points observed consistently. So this one is weekly, but is consistent. If it is daily, it must be consistent. If it is monthly, it must be consistent. So if you have missing value, so you have to look for a way of interpolating together. It is important to note this definition as you deal with time series data. You must look at your data. So let's run the next line of data to save our data set. Don't worry, we are going to open the data set again. Okay, it is time for us to open the data. Before we do that, we need to we need to remove the header. So this is done by assigning 0 to the header property, and we need to make our first column, that is the date, to be the index. I want you to note again that Python start counting from 0. So you can see me putting 0 here for the header. That means I'm removing the first set of row and the index column and making it to be 0. So it will be the first column and it will be date that will be inside that. Okay. So now we have gone ahead and we've run the code. As our tradition is, let's view the record again. Oh, that is interesting. Okay, so we have we can see the record, but there's something strange. It's not strange. It's based on what we have told the program to do. So we have converted the index column to be the date value. So if you look at the previous, like in the cell 8, the input out 8, you will see 0, 1, 2, 3, 4. Then if you come here, you will see that that 0, 1, 2, 3, 4 doesn't, they don't exist, that column doesn't exist again. Now we have the date. So it is what we have told the model to do. Okay. All right. So in order to check whether that this is really indexed, you can just do your data like this. You can see step, stop, no, one, the data frame. Okay, you can see this is a confirmation that we don't have other the numerical index column comprises of zero, a number ranging from 0 to whatever. But now we have the date values there. Okay. Okay, so that should be noted. All right, so we have confirmed. All right, so now we are looking at the data. So our weekly sales is still there. Our index is still also registered here. So let's plot the data as our tradition is. Okay, so as depicted by the chart, you can see upward and downward trend in the data, and also the cases of outliers. We have uh, look at that in detail, and these are originating from seasonality. We do not need to go through this in details, and we have already done that on that peculiarity of time series. However, it is clearly evident that in this 1 month sales forecast data, the fact is that it's not stationary. Okay, so ARIMA comes with a major assumption, which is the stationarity of time series data. Let us plot the autocorrelation of plot time series. So, but before we do that, we are going to decompose the data. So when we talk about the decomposition, so we are talking about distributing the data into level to check the level, to see the trend, the seasonality, and also the noise component. It's about taking a series as a combination of these. The level is the average value in the series. Trend is the increase or decrease value in the series. The repeating short time cycle in the series. Why is that seasonality? Noise is the random variation in the data set. We'll be able to plot this and we'll be able to get this value. So this is the first additional package we'll be introducing, which is stats model. So stats model, let's run it first. Stats model allow you to create some of those statistical model like regression, the one not the one of machine learning. So with this package, you will be able to do all that which you use the regular software, like for example, talking about SAS, talking about Stata, talking about SPSS, all those statistical software can do. With this package, you can be able to do that. It's just a matter of knowing which command to run. So this is the decomposition aspect, and we are using multiplicative approach. There are two major approach, which is additive one, where you had in this case now is the actual multiplicative approach we are using. And what are we multiplying? The level, trend, seasonality, and the noise. Okay, let's run this as well. Okay, okay, and let's do the plotting now. Okay, so we have a result here from the charts. So we can see something on the residual, the seasonal, the trend, and the observed value. So definitely you can see some trend here. The January data is not complete, so we have some missing values here. Okay, so that's our plot. Okay, I don't know why it's showing two. Supposed to be one. Let me rebuild it again. Still showing this second one. All right, it's fine. Let's continue. All right, so all these values that are plotted, in case you want to see them, you can just run your result. We save this thing, the value in the result. You can just say results.observe in case you want to see the observed value. So let me try with the first one, reserve. Okay, you can see the values here from the observe, the actual value. Then we can also see the trend. All right, it said it's missing. So as it's even been depicted, so we don't have some of the values here. Okay. So now let's go to the ARIMA proper. So we want to use the auto ARIMA approach. So this is the implementation here. We bring in some packages and we specify the parameters. So these are the default ones. You don't need to trouble yourself so much about this. Okay, so the AIC is being computed. All right, so everything is being computed. All right, so it has computed. So AIC, I think is archaic, if I still remember correctly, is a way of measuring, evaluating your model, the AIC and the BIC. But in this context now, our focus is on the AIC, and we ask this thing to print out our stepwise kind of AIC, and the best is 2758. Let's see where it is here. Okay, it's somewhere here. So this is our best fitted ARIMA something. Okay, So now let's check for the stationarity proper. We talked about that briefly when we started this video. Okay, let's look at it. So let's do the autocorrelation. All right. So it is evidently, so there's the assumption of stationarity is not being observed here. All right, so let's go to the implementation and use something and continue with the fitting. Okay, it's running.